Hello everyone, my name is Dheeraj Kumar and my roll number is 21 AG10011 and this is DIY team project and we are team A. These are our following members and the project we have made is smart irrigation system. And now the scope of our project is to automate the watering of plants with user-friendly interface and to display the water consumed for irrigating the soil along with the time of watering and the amount of water left in the reservoir, and to determine whether the soil requires SOM intake or not based on the time difference of two successive irrigations. This is our soil organic matter. So basically soil organic matter is used along with the soil to give plants sufficient nutrition and improve water holding capacity of soil, which in turn increases life of soil and save water. So basically when the water holding capacity of soil increases, the soil retains more water in itself for its growth, and hence the frequent water consumption by the soil is reduced by adding soil organic matter. And these are the following purposes we will be satisfying through this project: to save water and to maintain plant and soil life through SOM, and to save environment through this healthy plant and healthy soil. And we have also kept our web application part and the interface part user friendly and easy to understand by displaying the amount of water consumed after each irrigation and the time of watering along with the level of water left in the reservoir. And through this user friendly and easy to understand project, we aware and inspire people to plant more. So these are our purposes. Now introducing the concepts of SOM. Since water holding capacity depends on soil texture and organic matter, but it's not easy to change soil texture. So to improve water holding capacity, the only variable factor is soil organic matter. Now the steps to proceed for SOM demand information is to calculating the time difference between two successive water demands. Now this time difference will decrease in due course of time due to high temperatures, because SOM decomposes at high temperatures and thus effective water holding capacity decreases. When this time difference has reached its minimum value, let's say 20 minutes, it indicates that SOM is needed to reduce frequent water consumption, which in turn saves water and maintains the soil health.
Hello everyone, I am Venkatchan from Team A. Now I am showing the demonstration video in which we have tested our hardware with sandy soil. We can see that sandy soil gets enough water required for its irrigation, so the pump is off. Now we can see the Python files. HTML codes. And CSS codes, which were prepared on VS Code by one of our teammate Pradyum to demonstrate and run the web page, which shows time of watering, time for which the pump was on, water remaining in the reservoir, amount of water used for irrigating the soil. Now we can see the Arduino code which we used. Then in the web page, we can see that the current status of the pump is off, and in the water consumption data, we can see that the time of watering and amount of water used for irrigating the soil and time for which the water pump was turned on, also the water remaining in the reservoir.
Now moving towards the Tinkercad circuit and code part, we have components here: 9-volt battery, DC motor, Arduino Uno R3 board, relay, soil moisture sensor, positional micro servo motor, temperature sensor, and ultrasonic distance sensor. Now introducing these components, we have ultrasonic distance sensor, which is used to calculate the distance from the top of the tank to the water surface, and these calculations will be used to calculate the water left in the reservoir after each irrigation. And this is a servo motor which will be rotating and which will be used to ensure that the pipe on it is rotating throughout the container, and we have kept the range of angle from 10 degree to 170 degree instead of 0 degree to 180 degree to ensure that there is minimum wastage of water at the very extreme ends of the container. And this is soil moisture sensor, which when has a value greater than threshold value will turn off the DC motor as well as this servo motor. We can see here clearly that it immediately stops whenever the value is greater than threshold value, and this is very sensitive, we can see here. And now this is relay, which is used to receive signals from the Arduino as when to stop and turn on the motor through the digital pin number 7. And this is temperature sensor, which is used to measure the temperature and which will be useful for SOM analysis. And now moving towards the code part, we have on the very start we have initialized the total height to 7.5 total height of the container and the pump status to off, and we have also initialized left water height to total height minus the ultrasonic distance sensor value, and also the temperature to the temperature sensor value, angle to 10 degrees as mentioned earlier, and soil moisture to the analog pin A0. And now we have included the conditions like if soil moisture is less than threshold value, then the pin number 4, which is the servo pin, will be rotated to 10 degrees, and the relay pin, which is 7 number pin, will be turned on, which will then turn on the DC motor through that 9-volt battery. And there's a loop in which we have included these two statements where soil moisture is read from the analog pin A0 and it's checked for its threshold value. And because as when the soil moisture value is greater than 160, the loop gets terminated at once at this very stage, and after that we have set the pump status to on and rotated the servo pin number 4 to the desired angle, which keeps on increasing by 10 degrees, which is responsible for the anti-clockwise rotation of the servo. And similarly we have another loop which is exactly same to this previous loop, except this statement which set the angle to angle minus 10, which makes the angle keeps on decreasing and which is responsible for the clockwise rotation of the servo. And after that we have a soil moisture greater than 160, a condition which checks whether the soil moisture is greater than threshold value, and after that it set the pin number 7, which is relay, to low and set the pump status to off. So this was all about the Tinkercad circuit code and circuit simulation.
Hello everyone, I'm Pradyum Mahajan, roll number 21AE 30017, and my contribution to our team project was writing the Python code, establishing a connection between Python, Arduino, and the MySQL database, and making the web application. First, let's take a look at the Python code. Here, we first establish a connection between Python and Arduino using the serial module of Python, which enables us to read the serial monitor of Arduino into Python. We then keep reading the temperature, the current pump status, and the height of the water column in the water reservoir from Arduino serial monitor. We update these values into the current table of MySQL, which we have made from this function, and the insertion is done using this function. When the pump status becomes 1, or when the pump is turned on, we note down the time and the height of the water column, and we repeat this. We note these things again when the pump turns off. These values are used to calculate the amount of water used, and the time for which the pump was turned on. These values are then inserted into the irrigation table, which is created using this function, and the insertion is done using this function. Once the pump turns off for the first time, we start another timer and turn it off when the pump starts pumping water for the second time. The difference between these two values gives us the time between two successive irrigations. We then repeat a similar procedure to this again for the second irrigation. Once the second irrigation is completed, the data of the time of watering of both the irrigations and the time between two successive irrigations is inserted into the SOM table, which is created using this function, and the data insertion is done using this function. Now let's take a look at the code for our website. We have made our web application using the Django framework of Python. Our web application consists of 3 different pages, the URLs for which have been created as can be seen here. Now this index function gets rendered whenever our home page is opened. This function reads the values from the current table that we created in MySQL, and depending on if the current pump status is 0 or 1, it sends a suitable string off or on to the index.html file, this file, which prints the current status of our pump along with an image, this image of our project. Now, this function, water consumption, gets rendered whenever the water consumption page of our web application is opened. This function reads values from the current and the irrigation tables of MySQL. From the current table, it reads the current water level, which it uses to calculate the amount of water left in our water reservoir along with its percentage. And from the irrigation table, it reads the amount of time for which the water was turned on, the time at which the water was first turned on, and the amount of water used for irrigation. All of these values are then sent to the water consumption.html page, which displays them in a particular manner. Now, the SOM function gets rendered whenever the SOM analysis page of our web page is opened. This function reads the values from the current table and the SOM table. If the water holding capacity value in the SOM table, which is nothing but the time difference between the two successive irrigations, is greater than 2.5 hours or 9,000 seconds, then our soil does not require any more soil organic matter. Otherwise, our soil needs soil organic matter. This function then sends the temperature value from the current table along with the times of irrigation from the SOM table and the WHC value along with a suitable warning into the som.html file, which prints all of these values according on the web page. The base.html file is a template that I have made for each of our web pages, and the other 3 HTML files are simply an extension of this file with their body going here. This file connects the other three web pages using this navigation bar, whose code can be seen over here. The designing of our web page is done using this CSS code. Our home page design can be seen from these 2 functions. The water consumption design from these 4 functions, and the SOM analysis page design from the rest of the functions. Now let's take a look at our website. Here we can see the link of our web page. On clicking on the link, we have reached our website. Here we can see, based on the last inputted values into the MySQL, that the current status of the pump is on. Here is the pic of our project, and In the water consumption data, we can see the time of watering, the amount of water used for irrigation, the time for which the pump was turned on, and the water remaining in the reservoir along with its percentage. In the SOM analysis page, we can see that since the water holding time is 55 minutes and 4 seconds, which is way less than 2.5 hours, this soil requires soil organic matter. And here the temperature is displayed, and here the time of watering of the two irrigations are displayed. Thank you.